Yes. Well then, our next step is to talk about that inverse variation. And as we mentioned earlier, inverse variation is when the value of one variable, if x gets larger, the other variable has to get smaller, or vice versa. And this is usually referred to as a constant product. The direct variation was a constant ratio. So it was y divided by x was equal to a constant. The constant product means x times y, or y times x, is equal to a constant. A little bit more usable form looks like this: y equals k divided by x. So if we are told that y varies inversely as x, that is telling us y equals constant divided by x. So our next step, we might have y varies inversely with x, and y is 5 when x is 4. So now y varies inversely with x is still y equals that constant divided by x. But we have a second piece of information that's going to allow us to better define that relationship. Y is 5 when x is 4. So 5 equals k divided by 4. We're going to solve that now for k by multiplying by 4. So 5 times 4 is 20 equals k. So that means we can bring that up here and replace k in that formula. Y equals 20 divided by x. So we can take that to that next step. Y varies inversely as x, and y is 8 when x is 6. Find y when x is 12. So here again we have two pieces of information, and then we're asked to do a task. Y varies inversely as x. Y equals k divided by x. K over x. Y is 8 when x is 6. That's saying we replace y with 8. And k over, we're going to replace x with 6. So k over 6. And just like before, we're going to solve for k. So k is divided by 6. We're going to multiply by 6 to get rid of it. 8 divided by 6 is 48. So 48 equals k. So we come up to our original relationship here, and we replace k with 48. So y equals 48 divided by x. And then finally, we have this piece of information we're asked to find something. Find y when x is 12. So y equals 48. We're going to replace x with 12. So 48 over 12. 48 over 12 is 4. So y would be 4 when x is 12. Okay. Oops. Y varies inversely I can't write today. With X, and Y is 9 when X is 4. Find Y when X is 6. So once again, Y varies inversely with X. Y equals K over X. Y is 9 when X is 4. So we put in 9 for Y, 4 for X. Solving for K, so multiply by 4. 36 equals K, or K equals 36. So Y equals 36 over X is that relationship now. Find Y when X is 6. So we put 6 in for X. 36 divided by 6 is 6. So Y is 6 when X is 6. And just like with our direct variation, we can complicate this. Y varies inversely. Y varies inversely as X squared, or the square of X, however you want to word it. Y is 9 when X is 2. Find Y when X is 3. So again, Y varies inversely as X squared. So Y equals K over, instead of X, it's going to be X squared. Y is 9 when X is 2. We put 9 in for Y. We'll put 2 in for X. This is 2 squared. And now we have an extra step to solve for K. We have to actually square the 2. So 2 squared is 4. And now we can solve for K. K is divided by 4, so we're going to multiply by 4. 9 times 4 is 36, so K equals 36. And we put that back up into our relationship to define it better. So instead of Y equals K over X squared, Y equals 36 over X squared. Finally, find Y when X is 3. Replace X with 3, so it's 36 over 3 squared. Three squared is 9, so Y equals 36 over 9. Y equals 4. Any questions? So applications of these. Dosage is directly related to weight. Now, directly related is the same as saying varies directly with weight, which makes sense. If your dosage is based on the weight, the more the patient weighs, the more their allowable dosage is. if a 120-pound patient is prescribed 8 milligrams, how much would be prescribed for a 180-pound patient? Now, when we were doing dosage calculations, we always converted our weights from pounds into kilograms. We could do the same thing here, but we don't have to. As long as they're both in pounds or both in kilograms, it will work out. It's the relationship between the dosage and weight that matters, not what the actual numbers are. And I'll show you that that's going to work out. So we're looking at this. The dosage is equal to a constant times the weight. The dosage is directly related or varies directly with the weight. 8 milligrams was the dosage for a patient who weighed 120 pounds. So solving that, we'll divide by 120 pounds. K is equal to 1/15 of a milligram. I'll divide it out. 0.0667 milligrams per pound. Because that was milligrams divided by pounds there. So what that's telling us is that this relationship, the dosage is equal to 0.0667 milligrams per pound times the weight, times the number of pounds. So now how much would we give for a patient who weighs 180 pounds? So D, the dosage, is equal to 0.0667 milligrams per pound times 180 pounds. 0.0667 times 180 is 12 milligrams. Might be some round off errors, might give you like 12.03 or something on your calculator. If we had chosen to convert those weights into kilograms, this would still have worked. 120 divided by 2.2 would be 54.54 kilograms. 180 divided by 2.2 be 81.82 kilograms. This probably should have been 55.55 up here, if I was rounding correctly. So I could do the same problem. Dosage is equal to a constant times their weight. Eight milligrams is equal to a constant times times 55 or 54.54 55. Yeah. I'm running in circles today. So we divide by the 54.55. Gives us 0.14665. That's milligrams per kilogram. It's a constant. So this relationship, the dosage is going to be 0.14665 times the weight. So we put in the 180, which is, we converted that to what? 81.82. So times 81.82. We had 11.999. So our dosage is still 12 milligrams. So as you can see, it doesn't matter whether we convert those weights from pounds into kilograms or if we just leave them as pounds. The direct relationship, the proportionality, will give us the same result. In chemistry, many of you had to take a chemistry requirement. In chemistry, the big example of this relationship is in the gas law, something called the ideal gas law. The ideal gas law states, and I'm going to oversimplify it here for a second, that at a constant temperature, remember we had said earlier that there's often a lot of other variables. We have to assume that those variables don't change, that those are constants. And that's what we're saying here, is at a constant temperature. So everything else is held constant. The volume of a gas is inversely related to the pressure. Well, so what that means is the volume is equal to a constant divided by the pressure. So let's say we are told that at a volume of 80 cubic inches, a gas experiences a pressure of 6 pounds per square inch. Find the pressure if the volume is reduced to 20 cubic inches. So remember, the volume is inversely related to the pressure. So V is equal to a constant divided by the pressure. So we're going to start out with, at 80 cubic inches, that's the volume, the pressure is 6. Now I'm going to leave the units off of this again. We're going to assume the units are consistent, and they are. I'm going to solve for K. K is divided by 6. I have to multiply by 6. 80 times 6 is 480. So K equals 480. So volume equals 480 divided by P. Find the pressure if the volume is reduced to 20. So 20 goes in for V. Now in this one, we're solving for the pressure, which was on the bottom of a fraction. The simplest way, the easiest way for me to do that is to make it a proportion. So I put the 20 over 1. And then I solve by cross multiplying. 1 times 480, which is 480, divided by 20. So the pressure is 24 pounds per square inch. So these, we had mentioned earlier, we have direct relationships and inverse relationship. The direct relationship is a constant proportion. And the inverse relationship is a constant product. In practice, we can use those to make this calculation a little bit shorter. For example, let's say the height of a truss, a roof truss, is directly related to the span. A truss with a 32-foot span is 8 feet tall. Find the height of a truss with, well, let's go 44-foot span. So we said it could be a constant ratio. Y over X equals a constant. Well, here we're going to define that to be Y is going to be the height. X is going to be the span. So the height over the span is a constant. So we have a truss that is 8 feet tall on a span of 32 feet. We're looking for what its height would be on a span of 44 feet. So we can set it up like that as a ratio, as a proportion, and cross, multiply, and divide. That height will be 11 feet. Now we could have done that with, again, dosages and weights, dosages and body surface areas, anything that has that direct relationship. We can set it up in a proportion. Now the other side, the inverse relationship, is a constant product. Let's go back to the gas law again. At $12 psi, it's pounds per square inch, that's a pressure. A gas fills, oh, what am I putting here? 48 cubic inches. How much volume will it need, or will it occupy at a pressure of 3 psi? So we said this is an inverse relationship. We know that. But we said an inverse relationship can be thought of as a constant product. constant product would be x times y equals a constant. So here we're going to look at that as pressure times volume equals a constant. So we have 12 psi at 48 cubic inches. So the pressure there is 12 psi times 48 cubic inches. And we want to know how much volume will it occupy at a pressure of 3 psi. So 3 psi times whatever that new volume would be. And now it's a matter of solving this. 12 times 48 is 576 equals 3 times V. We solve by dividing by 3. We get 192 equals our volume. Of course, that would be cubic inches because our other units were cubic inches. When I put it in this form, there is a formula we used in the last unit that is obviously an inverse relationship. And that was that change of concentration formula. Our change of concentration, remember, was concentration 1 times volume 1 equals concentration 2 times volume 2. If the concentration is reduced, the volume has to be increased in a related amount. So I might ask, find the resulting concentration if 120 milliliters of 36% solution is diluted to a volume of 300 milliliters. So then we use this formula here, C1V1. Well, we have 36% is our concentration times a volume of 120 milliliters equals C2 is what we're looking for times a volume of 300 milliliters. We multiplied 36 times 120. It's 44,320. And we divided by 300. So 4,320 divided by 300 is 14.4. So that new concentration was 14.4%. We could have solved this with that inverse relationship. Find the resulting, well, we know that the concentration is inversely related to the volume. So C is equal to K divided by V. The concentration is 36 when the volume is 120. We multiply by 120 to get K by itself. 36 times 120 is 4320. Equals our constant. So that relationship is concentration is equal to the constant of 4,320 over the volume. And we're now finding the concentration when the volume is 300. So C equals 4,320. Putting 300 in for V, we divide the concentration as 14.4%. The idea of variation is a very powerful idea. If you know that two values vary directly or inversely, you can figure out the relation, and you know one case where it's been used, you know, one set of numbers, you can then use that to find other sets of numbers without knowing the formula like we've done here. Now there is something called joint variation. Depending on the textbook, sometimes called joint, sometimes called combined variation. And that is involving more than two variables at the same time. Bless you. If they use the term joint variation, the wording would often look like this. Y varies jointly with X and Z. What that is saying, Y is equal to a constant times X times Z. Y varies directly with both of them, in other words. If X gets larger, Y gets larger. If Z gets larger, Y gets larger. Now there is a third relationship here that is not direct, and that's between X and Z. If Y doesn't change, if X gets bigger, Z has to get smaller. Or the other way around. I prefer not to use the term joint variation because it's not really clear. If a book is using the term combined variation, that's usually clearer to me. And the way it would word it is Y varies directly with X and Z. And that's that same formula. Y varies directly with X and, of course, with Z. So it's Y equals a constant times X, and that constant is also multiplied by Z. You could have Y varies directly with X and inversely with Z. Now, if they're using the terminology joint variation, this possibility isn't possible. But if they're using the combined variation notation, this is possible. Y varies directly with X. What that means is Y equals a constant times X. And inversely with Z, well, if it's inversely, it's the constant divided by Z. So it simply looks like that. Y equals K times X over Z. I will let you guys off the hook for our test. There might be, I believe there's mention briefly of joint variation in the last couple problems in your textbook. On the test next week, we will not talk about joint or combined variation. It'll all be strictly direct variation or inverse variation. And for you guys, it's an important concept to know, but most of what you really need to know is going to be that direct relationship with dosage calculation. If the dosage is based on their weight and you double their weight, you can double their dosage. Where it's most often used, by the way, is let's say a doctor orders 24 milligrams, and you look on the chart and the patient, their weight on the chart is 80 pounds, and you weigh them, and you realize that they actually weigh 90 pounds, either they were weighed incorrectly or that weight was from a previous visit and they weren't reweighed or whatever, you can use that to adjust their dosage. You know, the dosage varies directly with weight. So D is equal to K times W. So if the dosage was 24 when the weight was thought to be 80, divide out the 80. Oh, you're going to get what, the 3 over 10.3 equals K. So, you know, the dosage is 0.3 times the weight. You can put in that new weight of 90 pounds. 0.3 times 90 is going to be 27 milligrams. So you can adjust their dosage for their new weight. Okay, that is pretty much it for this chapter. So the new material we covered today in your book, page 231 to 235. We talked about this actually a little bit last week. Not a lot today. It's just reading those graphs and looking at the linear relationships and stuff like that. And then on the variation, it's page 240 to 241, 1 through 21, the odds. Some things for the test that I'm just going to give you a heads up that students struggle with. So I want to make sure it's out there. The variation is one that we just covered that students tend to struggle with on this test. The other one is, if I were to ask you to graph something like y equals negative 2x plus 5. Oh, sorry, negative 2x squared plus 5. Since that's a parabola, we're going to make a table of values, x and y. And you might pick, I think on the table I'll give you values like negative 3, negative 1, 0, 1, and 3. So this is negative 2 times negative 3 squared plus 5. I have several students that will come up with 23 for that. Because they'll punch it in their calculator like this. Negative 2 times negative 3 squared plus 5. Comes up 23. What did I do wrong? The exponent, that should have been negative 3 in parentheses. And then squared plus 5. It's actually a negative 13. So be very careful with that. Other than that, the only other thing I will give you a forewarning on the test. These tests were made district-wide. This is not one that I made. And I'm not saying it's not a bad test at all, but one of the things I don't like about it is this. If you're looking at a graph, it's labeled like this. When you're looking at that, if a point is right here, it's really easy to try to call that 6. What is it really? It's 5. This is 1, 2, 3, 4, 5. So make sure you're very careful seeing what, when the numbers are there, what one it actually lines up with. Most of them you can just count it out anyway, so you don't have to rely on the numbers. Okay, so again, those are the pages to work on. You guys have a great weekend. We will see you for the test next week. I will send that test next week out on Wednesday or so as well, so it's there if you want to take it Thursday or earlier in the day Friday. Is there anybody that needs to take it earlier than Wednesday afternoon? Okay. Okay. So we'll see you guys on Friday then.